So we didn't quite finish this first little section about limiting reactants. We've got one example left. So consider this reaction, sodium reacting with fluorine to form sodium fluoride. It says you begin with 4.8 moles of sodium and 2.6 moles of fluorine. What is the limiting reactant and theoretical yield of NaF in moles? Okay, so we read the problem, and then we take the information and we write the amounts under the formulas in the balanced chemical equation. So it says 4.8 moles of sodium. So I'm going to put 4.8 moles under sodium and 2.6 moles of fluorine, 2.6 moles of that. And the question is, how many moles of sodium fluoride? Before we started talking about limiting reactants, what would happen is they would give you one of these and ask you for an amount of something. Now they're giving you two amounts. That should be the big clue that this is a limiting reactant problem. That, of course, and them asking you what the limiting reactant is. Limiting reactant problem, we're going to do two equations, but they're going to find the same thing. So we're going to take this amount of sodium and find out how much sodium fluoride we can make. Then we're going to take this amount of fluorine and find out how much sodium fluoride. Just like with the pancakes, we took each ingredient and figured out how many pancakes we could make, and then we choose the smaller one. So the mantra for stoichiometry is grams to moles to moles to grams. Grams to moles to moles to grams. But you have to look at the individual problem. Are we going to use that whole path in this problem? No. We're starting with moles and we're ending with moles. So this is easier. We can cut the ends off. You can't turn it inside out and go moles to grams to grams to moles. People try that, but you don't get anything meaningful. Okay, I like to do the first one first and the second one second. 4.8 moles of sodium, and I want moles of sodium fluoride. So then I put moles of sodium in the denominator. And where do the numbers come from? Coefficients in the balanced chemical equation. There's a 2 in front of sodium. So I'm going to write 2 in front of sodium. There is a 2 in front of NaF, and so I'm going to write a 2 in front of NaF. And we can do this one without even using the calculator. It's going to be the same, isn't it? 4.8 moles of sodium fluoride. Easy ones like this are the best place to practice writing the stuff down. Okay? Write it down when it makes sense, so that when it doesn't make sense, you can write it down and come up with the correct answer also. Then 2.6 moles of F2. And again, we're going to moles of sodium fluoride. Now I want moles of fluorine in the denominator. And again, I go to the balanced chemical equation and look for numbers. Well, in front of F2, there's an unwritten 1. So in front of moles of fluorine down here, I could leave that blank and understand that it's a 1, or I can stick a 1 in there. And in front of NaF, there's still the number 2. So this should give me 5.2. Check my math. I did that in my head. It's usually a dangerous thing for me. I've got 2 answers. I can only have one answer for the yield. Which one do I choose? The smaller one. Okay, this is how much I can make. Because when I make that much product, I have used up all my sodium. You can't make more sodium fluoride without sodium. So this is the answer to what is the theoretical yield. That's the theoretical yield because that's going to assume that everything goes perfectly. And as we know, when we're making cookies or pancakes or something, it doesn't always go perfectly. What's the limiting reactant? The reactant that gave us the smallest yield. The limiting reactant is the one that limits how much product you can make. It's the one that we run out of. So there's our our theoretical yield, and sodium is our limiting reactant. Any questions?